Hello everyone, welcome to LRDIprep. My name is Samir Sardana and in this video I'm going to cover a CAT 2020 slot 3 set. It's a distribution and scheduling based set. I have never seen a better set in the CAT compared to this set. This is one of the best set in the history of CAT. So many concepts to learn from this set, guys, and really a tricky set to solve in CAT exam. My name is Samir Sardana. I have done my MBA from UBS Punjab University, Chandigarh. I have 10 years of experience of teaching for CAT exam. I'm teaching on Unacademy Plus. You can attend my live classes on Unacademy Plus for Quant and DALR section using my referral code LRDISpeed Live. This will give you 10% off. And if you like this video, please rate this and share this. Let's have a discussion on this set. So guys, here is the set that we are going to cover. It says that XYZ organization got into the business of delivering groceries to home at the beginning of the last month. Now they have a two-day delivery promise. Now keep this point in the mind that they have a 2-day delivery promise, right? However, their deliveries are not unreliable. An order booked on a particular day may be delivered the next day or the day after. For example, if I'm placing an order on Monday, I'll be getting that order either on Tuesday or on Wednesday, right? So there's a 2-day delivery process. So for example, if I talk about the date, if I'm placing an order on 10th of any month, I will be getting that order 11th of that month or 12th of that month. If the order is not delivered at the end of the 2 days, then the order is declared as lost at the end of the second day. So if let's say if I'm placing an order on 12th, I'm not getting order by 14th, that order will be considered as lost. XYZ then does not deliver the order but inform the customer, marks the order as lost, return the payment and pays a penalty for non-delivery. The following table provides detail about the operation of XYZ for a week of the last month. Now this is a scheduling of 1 week of the last month. It's about cumulative orders booked, order delivered on that day, and cumulative orders lost. So that means by 13th of that last month, the total number of orders that have been booked till 13th are 219. And order deliver on day. Now on 13th, now think guys, if I'm delivering an order of 13th, that must be placed either on 11th or on 12th because it's a 2-day delivery process. So on 13th, I'm delivering 11 orders. These 11 order must be of the date of 11th or of 12th. And total number of orders which have been lost till 13th are 91, right? Now, when I go to the 14th, you see that the total number of cumulative orders booked are 249. So can I say that the difference between these two is of 30? And this gap of 30 is basically telling me that by 14th, the total number of orders are 249. So can I say on 14th, the number of orders placed are 30. If I'm specifically talking about this date, there will be 30 orders that will be placed on 14th, right? Orders delivered on 14th are 27. Now tell me, think guys, if 27 orders are delivered on 14th of a month, can I say that these 27 orders must have been placed on 12th or on 13th, right? So because it's a 2-day delivery process. Now you see that total number of cumulative lost are 92. Now there is an increase of 1 in the order lost. Now when do you count an order as a lost order? When the delivery does not happen after 2 days. So can I say that if on 14th I'm increasing the cumulative order lost by 1. If I'm increasing the cumulative order lost by 1, can I say that this lost one value, the order that I'm losing here, the one value that I'm losing here, the one order that I'm losing here must be from the order that must have been placed on 12th. This lost must be from the order placed on 12th, because if I'm counting it on 14th, that means the order which have been placed on 12th and still not delivered till 14th will be counted as lost. So this one increment must be of 12th date, right? So this is how you are supposed to read this complete table, make a full table to answer all the question, and it's very, very tricky. You have to find out what are the number of orders that are placed on each of these dates to answer the set. Then you also need to find out of the orders of a particular date, how many orders are placed, how many orders are delivered on the next day, and how many orders are delivered on a gap of 2 days. So for example, if I'm saying that 30 orders have been placed on 14th, out of these 30 orders, I'm supposed to find out how many orders are, how many orders will be, how many orders have been placed on, how many orders have been delivered on 15th, how many orders have been delivered on 16th. That's something that you need to find out to answer all the set. And there's an information here. It is known that the number of orders that were booked on 11th, 12th, and 13th of the last month that took 2 days to deliver were 4, 6, and 8. That means all the orders that I am placing, all the orders that I am placing on 11th, out of all the orders that I have placed on 11th, 4 orders have taken 2 days delivery time. That means these 4 orders must be delivered on 13th. There's 6 such orders which I am placing on 12th, but they are taking 2 days to deliver. So that means these 6 orders must be placed on 14th of that month. 8 orders have been placed on 13th and it takes 2 days to deliver. So can I say that on 15th I'm ordering this? On 15th these 8 orders have been delivered. Now this is the table that you have to make to solve the whole set. Write down the name of the day, right? The date of the days, right? And then cumulative order booked as per the given the table, right? These are the values that I have taken from this table as it is. I'm just adding 2 more days here, 11th and 12th, because I have an information regarding 11th and 12th. How many orders placed on 11th are taking 2 days? How many orders placed on 12th are taking 2 days? So you need to make this column. Then you need to find out what are the number of orders which are placed on particular day. Orders delivered, how many orders have been delivered on that particular day has already been given in the table, right? So I have taken these values from this. But what I need to find out is how many orders are delivered on n+1 day and n+2 day. This is the column I need to fill in to answer the question. And cumulative order lost were given to me. I will be now finding this lost, right, which is happening is of which day, right? For example, here the increase of 1 is a lost of 12th day, so we will be counting it, right? So we have to find out this column also. Now, first of all, where should I start solving the set from? You can start solving the set from here directly. On 13th, my cumulative orders booked are 219. In 14th, the cumulative order booked are 249. So can I say the increase is of 30, and the increase of 30 is nothing but the number of orders which are specifically placed on the 14th of that month. Next, 14 to 15, the number of orders are getting increased by 28. So can I say that these 28 orders are placed on 15th of that month? Then you go further, the increase is 25 and the number of 25 orders are placed 16th of that month. Then again, there's an increment of 25 in the cumulative order. So these 25 orders must be placed on 17th of that month. Then there's increase of 5. This would be of 18 and increase of 5 again. This must be of 19. Okay. Now the information given is that the number of orders which I'm placing on 11th, out of those order, right, 4 orders are placed on n+2th day. That means if I'm placing an order on 11th, that order will be delivered on 13th and that number of orders are 4. Okay. And if you look at 12th, the number of orders given are 6 as per this statement. I'm using this information. The number of orders placed on 12th, delivered on 14th are 6. Number of orders placed on 13th and delivered on 15th are 8. Now, you see that if I look at the number of orders of 13th, there are total 11 orders which are delivered on that day. Now just try to think these 11 orders which are delivered on 13th, these orders must be placed on 11th or 12th because it's a 2-day delivery process. So all these 11 orders must be, some of these orders must be from 11th of that month, some of these orders must be from 12th of that month. Now look at here. Out of all the orders that I'm placing on 11th, four orders are taking 2 days. That means these four orders are delivered on 13th. So can I say that out of 11, can I say that four are the orders of 11th? So can I say that rest of the seven orders must be of 12th? So out of all the orders which I'm placing on 12th, seven orders are delivered on next day and six orders are delivered on 14th, and there is a lost counted of one, and this lost must be of 12th day, because a lost is counted, an order is counted as a lost order when it is not delivered after 2 days. So if on 14th, if my order lost is getting increased by one, this must be of 12th, because the order which is placed on 12th, and if it is not delivered till 14th, it will be counted as lost. So if there's an increase of one, so can I say this is a lost order of 12th of that month. So how many orders are placed on 12th? 7 plus 6. 7 are delivered on next day, 6 are delivered on 14th, and 1 is lost. So total, can I say that on 12th, can I say the number of orders placed are 14? Yes, the number of orders placed must be 14. Now if you look at 13th, look at here guys. If I look at 14th now, out of 14th, you see that the number of orders delivered on that particular day are 27. And the 27 orders which are getting delivered must be of these 2 days, 12th and 13th. Now, I know that there are 6 orders of 12th which are taking 2 days delivery point, 2 days delivery time. So can I say out of these 27, 6 are the orders which are placed on 12th. So can I say rest of the 21 must be the orders which are placed on 13th but delivered on 14th. So these are taking 1 day to deliver. So I will be writing down the value 21 here. That means they are taking 1 day of delivery time. Now, when I'm moving from 14 to 15, the number of increase in the lost is 2. Now tell me which order will be counted as a lost order on 15th. Order which are placed on 13th, not getting delivered till 15th will be counted as lost. So can I say there's an increment of 2? So there will be a lost of 2 orders on 13th. Now out of all the orders placed on 13th, 21 are delivered on the next day. That means on 14th, 8 are delivered on 15, that means taking 2 days, and 2 orders are lost. 21 plus 8, 29 plus 2, 31. So can I say on 13th, order placed must be 31, out of which 21 are delivered on the next day, 14th, that means 8 are delivered on 15th, and 2 are lost. So now, if 219 are the cumulative orders booked, and on 13th I have 31 orders placed, so can I say till 12th, the number of orders must be 219 minus 31, 9 minus 1, 8, 11, must be 188. So till 12th, the cumulative order must be 188. And out of 188, 14 orders are delivered on 12th. So till 11, the number of cumulative orders must be 188 minus 14. That means 174, right? Okay, so we got this column completed, this column completed. We need to complete this column and our job will be done, and that's it. We are done with this set then. Now look here guys, on 14th, you see that we have taken care of all these 27, right? Out of these 27, 6 are of 12th, 21 are of 13th. Now look at 15th. On 14th, the number of orders that you're placing are 30. Can I say that out of these 30 orders, some of the orders will be delivered on 15th and some will be delivered on 16th. Now, order delivered on 15th are 23. Now, the orders which are delivered on 15th must be placed, some of the order must be placed on 13th, some of the order must be placed on 14th. I know that there are 8 such orders which are placed on 13 and taking 2 days delivery time. That means these 8 orders must be delivered on 15. So can I say out of 23, 8 orders are from 13. So the rest of the orders, 23 minus 8, that means 15 must be of 14th, right? Now, 30 orders are placed. 15 has been delivered on 15th, right? And then if you look at the increase in the number of lost order, When I'm going from 15 to 16, the increment in the number of lost order is given to me as 6 plus 6, that means 12. And these increment of 12 is because of the 12 orders which have been lost, and these 12 orders which have been lost must be of 12th, right? Or must be of 14th, because these 12 orders which are placed on 14th, not delivered till 16th, will be counted as lost. Now, look at these 30 orders. Out of these 30 orders, 15 have been delivered on the next day. We have already seen it. Some will be counted, will be delivered on 16, but we don't know that value. Out of 15, 12 are, out of 30, 15 are delivered, 12 are lost. We are left with 3 more orders. So can I say that 3 such orders of 14th which are delivered on 16, that means they are taking 2 days delivery time, right? They are taking 2 days delivery time, right? Correct. Now let's move further. On 15th, I have 28 order placed. Now total number of orders which have been delivered on 15th are 23, out of which 8 are from 13th and 15 are from 14th. 8 plus 15, 23. We have already sorted out this thing. Now look at the value of 16. 11 orders are getting delivered on 16th. Can I say the orders which are getting delivered on 16th must be placed on 14th and 15th? Some of the orders must be placed on 14th, some of the order must be placed 15th. I know that all the orders out of 14, 3 orders out of 11 are of 14th. So rest of the 8 orders must be placed on 15th. So total 28 orders are placed, out of which 8 are delivered on the next day. Some will be delivered on 17th, but we don't know that value. But we can see that the increase in the number of lost is 12. So can I say that these 12 increment of the lost order must be because of those orders which are placed on 15th, because they are taking 2 days and still not getting delivered, so will be counted as low. So these 12 orders will be coming here at 15th position, right? Now look at here, guys. Out of 28 orders which are placed on 15th, 8 are delivered on 16th, 12 are counted as lost. How many I'm left with? 8 plus 12, 20. I'm left with 8 more orders. So 8 more orders of 15th must be delivered on the next of the day. That means on 17th. Now, out of 21 orders which have been delivered on 17th, I can see that 8 orders are of 15th. So can I say rest of the 13th order must be of 16th? Rest of the 13th order, 13 order must be of 16. Now 25 orders are placed on 16th, 13th are delivered on the next day, that means on 17th. Increment in the lost is of 2, so these must be the lost of 16th orders placed. So out of 25, 13 are delivered, 2 are lost. I'm left with 10, so those 10 must be delivered on 18th. Out of 13 orders which are delivered on 18th, 10 are coming from 16th. Rest of the 3 order must be rest of the 3 order must be of 17th. Out of 25, I have 3 orders getting delivered on the next day, that means on 18th, right? And on 19th, the number of lost order are getting increased by 9, so this must be a lost of 17th day order place. Out of 25, 3 are delivered on next, 9 are lost. 9 plus 3, 12. Out of 25, I know what is happening with these 12, so rest I'm left with 13 more orders. So can I say this will be the value that will be coming over here? So out of 25, 13th order are delivered on the 19th, right? Now out of these 14, I know that 13 are coming from 17th orders place, right? So 14 orders which are delivered on 19th, 13 are placed on 17th. So I'll be left with 1 more order, and that 1 order must be of 18th, right? Now I don't have any more figure to identify how many are lost, so I will not be able to fill in this information, right? So out of 5 orders which are placed on 18th, 1 is getting delivered on 19th. What is happening with the rest of the orders? We do not know, because we do not know what is happening with the lost, right? That's it. This is the complete table that you have to make to answer all the questions now. We now know how many orders are getting lost on a particular day, how many orders are delivering on next day, how many are taking 2 days to deliver time. Now you can answer all the questions. Let's have a look at the first question. Question number 1 says, among the following days, the largest fraction of orders booked on which day was lost? So how many was booked and how many was lost? So where is the largest fraction? Out of all the orders which are booked and the orders which are getting lost. So lost as a percentage of booked is largest in which number? 15, 16, 13, 14, 15, 16. If I look at 13th, 31 order are placed and out of which 2 are lost. So on 13th, I have a fraction of 2 by 31. If we look at 14, 30 orders are placed, 12 are lost. 12 out of 30 are lost. So that's a fraction of 14. 15 and 16. 15, 28, 12 out of 28 and 2 out of 25. 12 out of 28 on 15th and 2 out of 25 on 16. So if I have to compare the fraction, I can see that these are straight away eliminated. The fight is only between two fractions, that is 12 by 28 and 12 by 30. Again, there's no fight. The denominator here is small, so this value will be more than this. Numerator is same, but denominator is small here. So on 15th, the number of orders lost as a fraction of total orders booked is highest in 15th. Right. 15th is the right answer. Let's look at the next question. On which of the following days was the number of orders booked the highest? Number of orders booked. Okay. So I'm supposed to tell in which particular day highest number of orders are booked. The highest number of orders are getting booked. You can see that on 13th, right? The placed number of orders, the highest number of orders getting booked are on 13th. So 13th will be the correct answer of the question, which is option number 4. Let's have a look at question number 3 now. It says the delivery ratio is just a calculation based question, right? Our job is almost done. The delivery ratio for a given day is defined as the ratio of the number of orders booked on that day, which are delivered on the next day, to the number of orders booked on that day, which are delivered on the second day after booking. On which of the following day was a delivery ratio high? So delivery ratio for a given day is defined as ratio of the number of orders booked on that day, which are delivered on the next day. So basically the number of orders which are delivered on n plus 1 day and the number of orders which are delivered on n plus 2 day. That's my delivery ratio. And I'm supposed to tell which in which of this day delivery ratio is highest. Now I can see that on 13th, if you look at on 13th, n plus 1 upon n plus 2 is 21 by 8, right? On 13th, this value is 21 by 8. On 14th, 15 and 16, let's check it. On 14th, 15 and 16, 15 by 3, 8 by 8, 13 by 10. 15 by 3, 8 by 8. 15 by 3 and this is 8 by 8. Sorry, 15 by 3 is of 14th. 15th, it is 8 by 8. If I talk about 16th, it is 13 by 10. Now tell me, in which particular case the delivery ratio is highest? You see that this is 3 by 15. 15 by 3 is 5. None of the fraction is close to 5. So the answer will be 14th. 14th, it is 15 by 3, right? 14th, it is 15 by 3. So on 14, it is highest. That would be the correct answer of this question. This question came in CAT 2020 slot 3, right? A beautiful set, guys. Very, very important one. Now let's look at one more question, question number 4 of the set. It says, the average time taken to deliver orders booked on a particular day is computed as follows. Let the number of orders delivered the next day be X and the number of orders delivered the day after be Y. That means if the number of orders delivered on n plus 1 is X and the number of orders delivered on n plus 2 is Y, then the average time to deliver the order is taken as X plus 2Y upon X plus Y. Now I'm supposed to find out on which of the following day was the average time taken to deliver the orders booked the least. So 13, 14, 15, 16. Let's write down the values first. 13, 14, 15, 16. 13th we have 21, 8, 14, 15, 3. 21, 8, 15, 3. 21, 8, 15, 3, 13, 14, 15 and 16. 15th we have 8 by 8, 16 we have 13 by 10. 8, 8, 13, 10. 8, 8, 13, 10. Now if I apply this formula which is given to me in the question, n plus 1 value is this first value written in the bracket, n plus 2 value is the second value written in the bracket, x plus 2y upon x plus y. Now x plus 2y, 8 plus 2 into 8, that means 8 plus 16 upon x plus y, that means 16. That is 24 upon 16, which is 3 by 2, which is 3 by 2, which is 1.5. 21 by 8. Now if I look at this fraction here, this would be 21 plus 2 times of 8, that is 16. 21 plus 16 would be 37 upon 21 plus 8, 29. 37 upon 29. If you look at this value, 13 plus 2 times of 10, which is 20 plus 13, 33 upon x plus y, that is 23. If you look at this fraction, 15 plus 2 times of 3, that is 21 upon x plus y, that is 18. I'm supposed to find out which fraction is least. This you can see that 3 into 7, 7 by 6. 7 by 6 is, it would be 1.16 something. This is 1.5 something. If you look at 37 by 29, it would be 1 plus 37 and 29 have a gap of 8, 8 by 29. Okay. And this is 1 plus gap of 10 upon 23. Now, if I have to compare these values, you need to be very comfortable with a fraction. Now, 1 upon 23 is 4.34. If I multiply 0.0434, right? Or in terms of percentage, 1 by 23 is 4.34. Multiplying it by 10 would be 43.4. So the final would be coming out to be 1.434, right? This would be the fraction. If I look at this fraction, 1 plus 8 by 29, 1 by 29 is 3.45. And if I look at 8 by 29, this would be 8 times of it. 8 into 5, 40. 4, 8 into 4, 32, 32 plus 4, 36, 3, that is 27.60. So this comes out to be 1.2760. So if I have to find out the least fraction out of these, this is 1.5, 1.2760, 1.434, and this is 1.16. So 14th, you can see that this fraction is the least value. So the answer to the question is 14th. You can cross verify once again the calculation part. Main part was to make the table. Just cross verify the calculation. I'm doing it live here in front of you. There might be some error, but I'm 101% sure the answer should be 14 to this. Just again cross verify it. If there is any correction, I'll let you know in the comment section. See you then, guys. This was a set of CAT 2020 slot 3. Very, very important and beautiful set. Guys, to attend my live classes on Unacademy, you can use this code LRDIprep to get 10% off, and you can attend my Quant and DILR classes. This is a YouTube channel where you can cover your 100% syllabus. So subscribe to the YouTube channel LRDIprep and please share it with all of your friends. Target Cat with Samir is my Telegram group where I'll provide free content and free video classes to all of my students. So you can join this Telegram group. Link is given in the description part of this video. I'm coming up with a revision course of arithmetic with 500 must-do arithmetic questions. In this particular course, I'll be teaching some very, very important and selected questions, 500 arithmetic questions to help you with your revision comprehensively. And the start date is 30th of June. Timing would be 2 p.m. to 3:30 p.m. So must attend course for everybody planning for CAT 2021. Use the code LRDIprep to get 10% off. Bumper offer is also live on Unacademy. If you go for a plus subscription now, you'll get extra 1 month subscription to prepare for SNAP, IFT, and ZAT exam preparation. Also, you'll get 10% additional off with my code. Please like this video if you like. If you have seen this video completely and if you like it, please like it. Click the like button, share it with all of your friends, and please comment for any doubts in the comment section. Thanks a lot. See you in the next part.